So in Turbo Design 1, we can start a new optimization using this option here. And then we select the target case, which is the baseline rotor, and then the workflow, which is rapid single point or MOGA, and then specify some optimization settings. And with that, let's open the various Optima related windows and rearrange them a bit first. So for the input parameters, we can see that the stream-wise loading parameters have been pre-selected. And we can also add the trailing edge RVT star parameters like this. Because they can help reduce the lean or wrap and hence the blade stresses. And of course, it's possible to set the range of variation for the different parameters as required. Proceeding to the constraints, we already have the throat selected, and we can add the diffusion ratio and some UDPs for wrap angle control and to constrain the turbine work like this. And then set their appropriate ranges. And then finally, coming to the objectives, we want to minimize the profile loss and some other UDPs for wrap angle control and leaving kinetic energy to increase the rotor efficiency. But also keep the blade stresses in check. And with that, we can also remove the secondary flow factor, which we don't need. And then we are ready to start the optimization, which we can do by clicking the run button here. Now once the optimization is complete, which is very fast and only takes an hour or so on an office workstation, we can see that these designs have appeared on a scatter plot between any two of the objectives. And then we can choose to see the feasible designs which respect all of our specified constraints. And next, we can also choose to see the Pareto front of optimum designs. from which we can pick and analyze any design of interest. And in this case, we select the design that gives us the lowest combination of maximum bow and maximum deviation, which will bring us as close as possible to a radial filament design. Now we can also check where our selected design sits in terms of the other two objectives like this. And although it doesn't have the lowest values for profile loss and leaving kinetic energy, but they're still quite reduced compared to the baseline rotor. And so the selected design can be expected to give us a better efficiency. And then with this option, we can generate the optimized design and then compare its performance parameters with the baseline rotor in the project manager window. And clearly, all the wrap angle UDPs are much improved, and if we then compare the blade geometries in the 3D plot like this, then we can easily see that the optimized blade is actually looking quite close to a radial filament blade and should lead to a safe turbine operation. And therefore this design can be exported for a CFD and FEA analysis, and in this way a rapid multidisciplinary optimization can be performed in Turbo Design 1.